Let's talk about quantum physics. Quantum physics is the fundamental part of history of modern physics. Before we get into it, let's start at the very beginning that started it all, the discovery of electrons. J.J. Thomson discovered electrons in 1897 when he was studying cathode rays. He created what is called a cathode ray tube, in which he pumped the air out of the tube, creating a very low pressure inside the tube. Then he applied a high electrical voltage between the two electrodes at the end of the tube. When an electrical voltage is applied, Thomson discovered a stream of particles coming out from the negatively charged electrode, called cathode, to the positively charged electrode, called anode. The ray is called cathode ray, or as we know it now as electrons. How he discovered there is in fact a ray emitting from the cathode. He saw a glowing spot at the end of the tube. Thomson's experiment helped us visualize the wave-like behavior of light because it shows how light travels through a medium the way it travels to a consistent path. Since they travel like waves, their wavelength can be measured. This discovery helped Max Planck form his hypothesis on blackbody radiation.
All objects emit energy in the form of electromagnetic radiation. A blackbody is a theoretical object which is capable of absorbing all radiation emitted on it, reflecting or transmitting none. Blackbody is a hypothetical model which is a perfect absorber and a perfect emitter of radiation over all wavelength.
Planck came up with an idea when attempting to explain blackbody radiation, work that provided the foundation of his quantum theory. Planck proposed that atoms does not emit radiation infinitely, or any continuous value. Instead, they could only emit in multiples of small, distinct amount of energy called quanta.
Planck's hypothesis created a foundation for Albert Einstein. Albert Einstein discovered that light is composed of particles called photons.
Now, a long debate between Hooke and Newton is to prove whether light is particle or it is a wave. The debate was won by Hooke when a few experiments proved that light is a wave, until the photoelectric effect. If you shine a light with high enough energy to a metal, the electrons will be emitted from the metal.
Photons exhibit separate traits of wave and particles. At higher wavelength, they behave like wave, but at lower wavelength, they behave like particles. It is a fact that light does have momentum. But how can it be since light doesn't have any mass? Actually, to find the momentum of light, we need to use a special relativity formula that ends up with momentum equals to constant of Planck over lambda. Theoretically, if you have big enough solar sail, the light bounces off the sail and propel it forward.
Compton effect or Compton scattering is a scattering of a photon by a charged electron. The result of it is a decrease in energy and increase of wavelength of the photon, and part of the energy is transferred to the electron. Bohr model of an atom, electrons travel in defined circular orbits around the nucleus. In this model, electrons can jump from one orbit to another by emitting or absorbing energy. The Boyle hypothesis showed that wave-particle duality was not merely an aberrant behavior of light, but rather was a fundamental principle exhibited by both radiation and matter. All these great physicists left their contributions in the branch of quantum physics, and left us with a lot of possibilities to make some breakthrough in the future.